And another design consideration you need to think about is when you have several floors in a building, then you have signal bleed between the floors, and you can measure signal bleed during an active survey. And if it's a high signal bleed, then you need to stagger access points, because you don't necessarily need as many access points as you thought you did. I can show you. So if we've got our building and we've got 3 floors, and we stick our access point here, now we've got coverage through all 3 floors. So we don't want to add an access point right here, and then we end up with a circle because we are missing our coverage area here, missing our coverage area here. In reality, this is not going to be a perfect circle because there's still going to be some interference. And in fact, as I show you, it's going to probably be more like a wavy. It's not a big deal. You're not necessarily needing coverage right up in the ceiling or right down in the floor. So, and your AP is going to be horizontal. It's not going to be vertical, but you get the picture. So we can put our second and third AP here and here, and our fourth AP here, and we've pretty much covered the building. Keeping in mind the coverage is a sphere. I can't really show you 3 dimensions, but that's a general idea of how to install access points when you've got signal bleed. And then you need to consider a 2.4 or 5 gigahertz. So as you know, network devices, Wi-Fi devices operate on 2.4 gigahertz or 5. Newer devices can operate on 5 or 2.4 or both. So 5 obviously has a better performance and lower noise, but as a result of that, the 5 gigahertz signal doesn't travel as far. And the other thing you can think about is 5 gigahertz has 23 channels. So in a high density application where many APs overlap, you have many channel choices that you can use to make sure that the overlapping APs don't use the same channel. On a 2.4 gigahertz signal, you've got more noise, but your signal travels farther. And you need 2.4 if you're supporting all devices. So you should probably install access points that support both, unless you don't have any 2.4 gigahertz devices in your network, and you can turn off the 2.4 gigahertz frequency down the road once you phase those devices out. The other thing you need to consider is that since the 2.4 travels farther than the 5, you need to adjust the power on the 2.4, make it a little bit weaker, so that your 2.4 and your 5 gigahertz signals travel the same distance from the AP. And think about what country you're in, because FCC doesn't have a problem in this case, but other countries regulate which frequencies you can use. When we say 2.4 gigahertz, we're actually, we've got 11 channels. It's 2400 megahertz, let's say channel 1, and 2420 megahertz is channel 2, and 2440 megahertz is channel 3, because a channel is 20 megahertz wide. So some of those channels are illegal, and you have to turn them off. So figure out, which channels you're allowed to use in your country, and if you've got a Cisco access point or some other access points and you tell it the country that you're in, it'll automatically turn off the channels that you can't use. And then, as I said earlier, we can manually turn off the channels. We can also adjust the transmit power, to adjust the range that the signal is on. Data rate, channel width, fragmentation, those are all things you can adjust. You can adjust them granularly per access point. Of course, you can also set up Cisco radio resource management, and it automatically adjusts access point powers and channels. It does that by collecting data from the access points on your network and then adjusting the power and the channels. And if you install a new access point on an existing network, then RRM will take all the data that it has and automatically configure a new access point, monitor it, and adjust the neighboring access points so they all work together. Meraki's and other cloud managed access points do the same thing. They just do it over the cloud instead of locally. It's very useful, especially in a dense network where the access points are overlapping